Today we're going to start our unit on factoring, and we're going to start with a really basic concept, and that's factoring out of GCF, or greatest common factor. It's something that we learned when we were younger in elementary school, and now we're going to take the same concept and apply it to polynomials and different expressions. But before we do so, just kind of a warm up from what we covered yesterday with that multiplication of polynomials. So here, I have a times 3a plus 7. And yesterday I talked about building the box for multiplication. So you could do this one of two ways. You could see that this is just one term and distribute it evenly into the set of parentheses, which is probably what I would do simply because it's just one term. But if you wanted to build the box and use that box method that we talked about yesterday, um, then you could see that this is going to be a 1 by 2. So if I wanted to build that box, I would do it 1 unit tall by 2 units wide. A would get the left side, and 3a plus 7 would get the top edges, with each term getting its own individual edge of the box. And just like yesterday, we talked about filling in the box using multiplication. So a times 3a gives me 3a squared, and a times 7 gives me a positive 7a. Since there are no peanuts or there's no like terms, everything comes right out of the box, and we get 3a squared plus 7a. You would get the same thing if you chose to distribute your a, so a times 3a gives you 3a squared, a times 7 gives you 7a. The same thing can be done with the second example, and that's kind of what I'm going to do, is the alternate method, which is simply distributing that monomial. Mono just means one, so I only have one term out here on this outside edge, so I can distribute it. So negative 2 times 1 gives me a negative 2. And then I have m times m squared, which gives me m cubed. Negative 2m times a positive 6m. Negative times a positive leaves me with a negative. 2 times 6 gives me 12. And m times m gives me m squared. And negative 2m times a negative 1 gives me a positive 2m. I don't have any like terms, and so my answer is finished. If I wanted to do the third example, I could choose to build the box, or I could choose to distribute. I'm going to build the box for this one just so that we can see the different variables at play here. So I do have this whole thing is a one-term polynomial or a monomial. And the second is a binomial or a two-term polynomial. So I have a 1 by 2 box. I have 4x cubed y on the left, and I have x squared minus 2y at the top. And I'm going to fill it in using multiplication where the two squares, where the two edges meet or intersect. So for my first box, I have 4 times this invisible coefficient 1. So 4 times 1 gives me 4. I have an x. I have 3 coming in from the left, 2 coming down from the top. So I have a total of 5 x's in the box. And I also have a y. So making sure that we're looking at all those variables carefully. Do the same thing with the second box. 4 times negative 2 gives me negative 8. I have only 3 x's, but this time I have 2 y's. And so if I was to look at this in terms of simplifying it, I would have 4x to the 5th y minus 8x cubed y. So just looking at multiplying, kind of just like a little refresher from yesterday. So what we're going to talk about today is the basics for factoring. So I teach factoring by grouping, which works almost 100% of the time. And so one of the big key features of factor by grouping is to be able to recognize a GCF or greatest common factor inside of a set of parentheses. So what is factoring? Simplest form is basically what we just did. It's that 3a squared plus 7a. This is simplest form. This is, you've already combined like terms, you've already done all that. Factored form is if you can break it up into two different expressions that are being multiplied together. So each one of those sets of parentheses is called a factor. So polynomials that cannot be factored are prime, just like our numbers 1, 3, 1, 2, 3, 5, 7, 11, 13. All of those numbers cannot be divided by anything but themselves. So we call those prime numbers. So if I have something that can't be factored, we also call it prime. So a couple rules for factoring your greatest common factor is that we like to check for your coefficients first. So check your numbers first and then go back and check your variables and realize that you can have multiple variables. But the biggest thing is that you have to have it in each term in order for it to be a GCF. Second step is to divide each term by your GCF, and you'll see that I call them leftovers. And then number three, is to check your work by distributing. So if you wanted to go back in, build a box and check your work, you can do that. So here's what factoring by GCF looks like. So here's my first expression. And what I want to do is check and see first off if there is a greatest common factor between the number 3 and the number 12. So if you're good at your multiplication tables or your times tables, you know that 3 breaks down into only 1 times 3, and 12 can break down into 3 times 4. Now what I like to do is if I'm going to be looking for a factor or a GCF, I like to go ahead and break this down so I can only have prime numbers. So if I look at the number 1, that is a prime number. I cannot, split that up into any other numbers. And the same thing with 3. I can't get anything out of it. It's just 1 and 3. However, the 4 over here can be split up into 2 times 2. So what I'm going to do is I'm going to break that down so that I have 2 times 2. And so that I don't lose values, I'm going to bring that 3 down. So 12 is 3 times 2 times 2. Now, greatest common factor says you're looking for the exact same thing in both terms. So if I look at the 3 and I look at the 12, both of them contain a factor of 3. So I can say, well, my greatest common factor is 3. Then I go back and I check for my variables. I have an x in 1, but I don't have an x in the second term. Because I don't have it in the second term, it cannot be considered a greatest common factor because it's not common in either one of those terms. So my greatest common factor stops at just the number 3. If I wanted to write this in factored form, then I could write it as my GCF first, followed by my leftovers. So I'm left with only 1x, and I'm also left over with a 4. So that came from right here, that one factor from the 3, along with the variable that we couldn't use, and 2 times 2 gave me that positive 4. So those are my leftovers. You throw all the leftovers in parentheses. Same thing for number 2. If we're looking at it, I have the number, the coefficient, 7, and then I have the constant value 7. And this 7 happens to be negative, so I just want to kind of be aware of that. So my greatest common factor here very easily is the number 7, because that's all 7 has. You can't break 7 down. It's a prime number. It's just 1 and 7, so there we are. But if I was to take a look at each one of these, I could break 7y into 7 times y, and I could break negative 7 into 7 times a negative 1. Well, we mentioned earlier that our greatest common factor is what they share. So that's the 7. So if I wanted to write this in factored form, I could have 7. And my second factor would be everything that's not in common. So I have a y from the first term that is kind of lonely. And I also have a -1 from the second term. So if I was to factor this out, I would get 7 times y minus 1. If we look here at number 3, and I'm gonna skip around like I would if I was there, but I want to look at this one because this is where we start to introduce letters. So we start with our numbers first. So 8 and 36. And I'm going to break each one of these numbers down into its most prime form. So start with the number 8. I can break the number 8 into 2 times 4. I can't do anything with the 2. It's kind of done. But I can break down the 4. And the 4 is 2 times 2. So making sure I bring each factor down with every level that I do this. And the reason I do this is because you don't want to have to backtrack. You don't want to lose it. 36 can be broken down into 4 times 9. 4 can be broken down into 2 times 2, and 9 can be broken down into 3 times 3. So now if I'm looking for my greatest common factor, I'm looking at what is in both of these factor trees at the very, very bottom level. So I have a 2, I have a second 2, and that's all I have. So my greatest common factor is 2 times 2, which happens to be 4. So my greatest common factor is the number 4. So I've taken care of my numbers, and now I want to go back and I want to look at those variables. Well, if I look at my variables, my first term has the letter M, and my second term has the letter N. They have nothing in common at all. So I like to just kind of put them here, M and N. And the reason I do that is because if I want to look at all my leftovers, here I have a 2 and an M. I have a 3, and an N. So if I was to go back and write this in factored form, my GCF goes out in the front. So my greatest common factor is 4. And then if I wanted to write my second factor, it'd be all those leftovers, everything highlighted in yellow. So I had a number 2 and a letter M. And then I had a positive 3 times 3 times N. So 3 times 3 gives me 9, plus the letter N at the back of it. So this would be considered a factored form. So my greatest common factor is 4, and my second factor, or my remaining, is 2M plus 9. If we take a look on the back of your notes, all of these are pretty simple, pretty basic, but I want to jump into, let's do number 7. If I wanted to find the greatest common factor, I would start by, just doing exactly what we did on the front. I would look at my coefficients, 21 and 3. If I wanted to break that down, I could factor 21 into 3 times 7, and that's about it. And 3 factors down into 1 times 3. My 21 has the letter C, and it has the letter D, and my 3 only has the letter D. So if I was to look for my GCF or everything that they share, they would both have the number 3 and they both have the variable D. So my greatest common factor in this expression is 3D. Well, that must mean that 7C1 must be everything that's left over. So if I was to write it in factored form, I would start with my greatest common factor, which is 3D, everything in yellow, and I would multiply it by everything left over. So in my first term, I had a 7 and I had a C left over. And in my second term, I had a positive 1 left over. And so my factored form is 3D times 7C plus 1. Eight's exactly the same. So I look at my coefficients, 14 and 18, and I look to see what they have in common. So if I break the 14 down, I can break that down to 2 times 7. Both of those numbers are prime. They're done. 18 can be broken down into 2 times 9. 9 can be broken down into 3 times 3. And then that's it. If I look at the first term, it has the letter G and it also has the letter H attached. And if I look at the second term, it has an H attached and it's also negative. So I like to kind of throw in a -1 just to help my eyes remember, hey, that term's negative. So looking at what they have in common, they have a 2 and they have the letter H. So my greatest common factor is 2H. So that GCF is what's going to start my factored form. So if I have 2H as my GCF, then I'm left with a 7 and a G for my first term. So I could just write it down, 7G. And in my second term, I'm left with a -1, a 3, and a 3. So if I multiply all those together, I end up with a -9. And that is factored form for 14GH minus 18H. Now, when you have multiple variables, you're going to do the same process, except we're going to be really careful with how we write our variables. So again, start with those coefficients or those numbers. 15 can be written as 3 times 5. And this 15 carries 2 A's, and it also carries a B. And that comes from 2 A's and a B. 30 can be factored into 3 times 10. And 10 can be factored into 2 times 5. If I look at what variables it contains, it has an A and it also has a B. So my greatest common factor, again, is everything they have in common. So both of them share the number 3. Both of them share the number 5. And both of them share the letter A and a letter B. So my greatest common factor is a 3, a 5, an A, and a B, which simply equals 15AB. My second factor is everything left over. Well, in my first set of parentheses, I only have the letter A left over. In my second term, or my second group, I only have the number 2, so that 2 is positive. So I wrap that up in parentheses, and there's my factored form. So it works no matter how many letters you have. Let's take a look at one more. Let's look at 14. So the process again stays the same. We're going to check out those coefficients out front first. That 48 is negative, so I don't want to lose that. And I want to go ahead and factor that. So 18 can be factored into 2 times 9. And 9 can be broken down into 3 times 3. And then I want to go back and I want to look at how many variables it contains. So it contains 2 A's, 1 B, and 2 C's. My 48 can be broken down into 4 times 12. 4 is 2 times 2. 12 is 2 times 6. Every term that I do not use, I bring down with an arrow so I don't lose it. 6 can be broken down into 2 times 3. Those are all prime numbers, so that's done. And it contains 1 A, 1 B, and 3 C's. So A, B, and 3 C's. So my greatest common factor, again, is the monomial or one term that can be found in both of these. And I want to go ahead and remind myself that that 48 is negative, so I'm going to throw a negative in there and start looking for what they have in common. Well, they have the number 2. They have a number 3. They have the letter A, only one of them, the letter B, and 2 letter C's. So my greatest common factor is 2 times 3, 6, 1A, 1B, and 2 C's. So my greatest common factor is 6AB squared, or ABC squared. So in my first term, I have a 3 left over and I have an A left over. So that first term is 3A. In my second, I have a negative left over, a 2, a 2, a 2, and a C. So 2 times 2 times 2. 2 times 2 is 4. 4 times 1 more 2 is 8. And I attach the letter C. So here is my factored form. It works for questions like number 16, number 18, number 20, 22. All of this back page works and functions exactly the same. You just find what they have in common and take it out. So looking through here, I think they all look good. I want to close out with number 24 because that looks big. It looks scary. There's a lot going on here, and it just makes for a really good last question for the video. So checking out these coefficients. And again, if you're really, really good at spotting GCF, that's fantastic. Some of us still struggle, or sometimes the numbers are so big that we don't realize what they have in common. So I'm going to start with this first term, 3. Well, 3 can only be broken down into 1 times 3, and it contains 3 letter A's, 2 letter B's, 1 letter C. Negative 9, well, 9 is definitely 3 times 3, and I'm going to throw the negative 1 in there to remind my eyeballs that it's negative. It contains 2 A's, 3 B's, and 2 C's. So kind of just write them out like that. And last is the number 15. 15 can be broken down into 3 times 5, and it contains 1 letter A, 4 letter B's, and 3 letter C's. So for my greatest common factor, I need to find everything that belongs in all 3 groups. So I start with my numbers. There's definitely a 3 in each group. So my GCF starts off with the 3. They each contain the letter A, but only one. They all share only one A. Some have more, and that's fine, but they at least all have one in common. They all have a B, and they all contain a second B. So in my GCF, that would look like B to the power of 2. And lastly, they all contain the letter C, but only one of them. Some terms have more, but they all have at least one in common. So my greatest common factor is 3AB squared C. And then my second factor is everything left over. So I have a 1, an A, and an A. So that leaves me 1A squared. In my second term, I have the negative sign to remind myself it's negative, a 3, an A, a B, and a C. So that leaves me a negative 3, A, B, and a C. And lastly, I have a 5, 2 B's, and 2 C's. So a positive 5 with 2 B's and 2 C's. So if you break these down, if you're a color coder like myself and you like to keep things color coded, it really, really helps to look and see what they have in common, or circling the things that they have in common. And then everything that's not circled or everything that's not highlighted must be what's left over. So that is factoring with the GCF. It is crucial to master this skill, because this is what factor by grouping starts off with. It's everything has to do with that GCF. So finish up with the notes. You do have an assignment on Canvas to go ahead and get started with. And then if you have questions, just let me know.